previous content before coming. Okay, because Snell's law is such a topic. No matter how many times you read, you just get confused. So I'm just revising whatever we studied. Snell's law. Snell's law tells me that the ratio of sine of I over sine of R is a constant, and that constant is represented by eta, and eta is known as refractive index of a medium. Therefore, I will represent this as eta m, and I'm calling this refractive index of the medium. And when I write eta m out here, and I'm calling this refractive index of medium, this refractive index can be absolute or it can be relative. Now, if it is absolute, it is analogous to refractive index of the medium with respect to air, but it will be written always as eta m. In book, this can be also, that's fine, okay, eta m. And if it is relative, then it is refractive index of a medium 2 with respect to 1. In many books, it will be written 2 with respect to 1. I would say always follow this protocol. Now, since I'm writing it m out here, I'm presuming that it is with respect to air. And when it is written in this manner, the diagram is something like this, that the incident ray is always coming from air and entering into the medium. This diagram can be confused for you. It can be like this also. This is air and this is medium, means the same thing. यहाँ तक हम पढ़ चुके थे पिछले क्लास में. Okay, refractive index with respect to any. So when you go to Google and somebody tells you refractive index of glass, all they are going by is absolute refractive index. This was our class till last class, right? कहानी अभी आगे आज से. Okay, now we will not talk in terms of absolute now for the next half an hour. If we want to make it absolute, we will convert 1 as air. Okay, so my diagram for next half an hour is like this. Air is coming from a medium. Sorry, my diagram for next half an hour would be 1 minute. Hi children, let me draw it properly. My diagram would be interface, and for this is my interface, and I should have an incident ray. This is my incident ray. I should have a normal at the point of incidence, and this is my normal at the point of incidence, and I should also have a refracted ray. Further, this is my angle of incidence, this is my refraction. Diagram itself shows that this has to be a rarer medium and this has to be a denser medium because speed of light has fallen, right? I am calling this as medium 1 and I am calling this as medium 2. This will be my diagram for the next half an hour, right? Snell's law tells me that eta 2 with respect to 1, which in your book will be written as eta 2 1, okay, is given by sine of angle of incidence over sine of angle of refraction. Remember, incidence is always happening from medium 1. Is this clear? So far understood? Okay. However, children, eta 2 with respect to 1, can also be expressed as the velocity of light, okay, in medium. Again, upar 1 hai na, so medium 1. That's the beauty of writing the formula in this manner. You will never make a mistake, right? Medium 1 over velocity of light, right children, in medium 2. So I write this as V1 over V2. Can I write this? V1 over V2. Understood? Okay. I go back a little bit once again to absolute refractive index of medium 2. Absolute refractive index, but copy baad mein karna. Kabhi kya hota hai na? Pay attention when I'm writing and how I'm writing, because that's important. This is getting recorded. You'll get the class notes. Otherwise, you will again have to have the problem of seeing the video once again. Just see what I'm writing. I'm talking absolute refractive index. For 2 minutes, I'll talk absolute refractive index of 2. When I'm writing absolute refractive index of 2, I expect air to be here, right? And this as a protocol, I will always write as eta 2. Now forget about sin I sin r. If I want to express this, then it is velocity of light in medium 1 or medium air. So that velocity is known as c. What does c represent, children? C is velocity of light, very good, in air. And this value is, this is c, sorry, already mentioned. And this is 3 into 10 to the power 8 meters per second. Understood? C divided by V2. I am following the original formula itself. Original formula says, whichever medium you came from, consider the speed there. So in absolute, where did I come from? I came from air. So I will consider the speed in air. So it becomes C by V2. Has everyone understood this? I hope there is no doubt in this much portion. Clear? Amish, clear? Okay. So this was one more way. So now we can also write, now I can extend this formula with sin I by sin r applicable for this diagram. Where I've written 1 out here, I can also write V1 by V2. Children, is there any issue with anyone? Fine. Okay. Let's see one more. So what are the formulas are very important. Okay. The first formula that we got was sine of angle of incidence over sine of angle of refraction is given by eta 2 with respect to 1. Now by now you know very well that 1 is from where it is being incident, and go by the relative formula is best, which is also given by V1 by V2. Is this correct? Okay. Let me now write another formula, 1 with respect to 2. Ulta. 1 with respect to 2. 1 with respect to 2 can be written as what, beta? V2 upon V1. Right? Okay, let's make it more easy for you. Let's say eta 2 with respect to 1 is what, beta? V1 upon V2. Right? Can I not write this as 1 upon V2 upon V1? Just see, 1 divided by V2 upon V1, grade 8 rational numbers chapter, V1 upon V2, so which is V1 upon V2. That's what I have done. V1 upon V2 I'm expressing in this manner. I'm allowed to do that? Right. Can I write this as 1 upon V2 upon V1 means eta 1 with respect to 2? Same thing. If 2 is on top, so 2 goes on top. That means I get a very nice formula. Eta 2 with respect to 1 is same as 1 upon eta 1 with respect to 2. This is your third formula. Right? 1, 2, 3. Your third formula is eta 2 with respect to 1 is same as 1 upon eta 1 respect to 2. In your book, it will be written like this. 2 with respect to 1 is 1 upon eta 1 with respect to 2. Is this clear so far? Right? No cuff, no septic, nothing. And now we come to the third formula, which is the most used formula, which is known as Patal-Lok formula. So we will see our Patal-Lok formula. Patal-Lok formula will make you, that is, don't write Patal-Lok in exam. That is our formula, and that will help you solve any problem. But if you go with this, that's what I have told to even grade 12 guys also. Grade 12 also we have the same problems. Are we ready for Patal-Lok formula? Right? Come. This formula will be useful when they will give you two mediums. They will juggle with you. See, the question will come like this. They will give you a medium 1 and a medium 2. And then for medium 1, obviously you have two types of, you have a ABS RI plus a REL RI. Yes or no? Similarly for medium 2 also, I will have a ABS RI and I will have a relative RI. They will juggle you. They will give this one and this one, ask you to find this one, all sorts of juggleries they will play with you. How to encounter those juggleries? In fact, the first time when you asked me that question, when we were in mirrors, that sir, samajh mein nahi aa raha hai, these only were the problems. Okay, and we have many of such problems I've brought. Okay, so for that we will use a conversion formula. Conversion formula. Now, how this formula comes, you need not memorize. If you memorize, you'll make a mistake. Try to understand. In our language, this formula will be known as patal. I have named it patal lok formula. What does patal means? Underground. Underground world formula. Achha, don't write all these things in your exam, okay? You'll get beautiful laddus, which will be like motichur. So let's see. Refractive index, say, of a medium 3 with respect to 1. 3 with respect to 1. That means there is a medium 1 and a medium 3. We will introduce another medium, which will be medium 2. Whenever I write this, and pay attention, don't write anything. First, introduce an imaginary line in your mind like this. This is the ground level. Anything below it is patal, anything above it is the land. Okay? And bring your concept of rational numbers. Have you understood? I have 1 on top, say I can keep 1 on top, and say I brought 2 out here. Right? I have to finally get 3 at the bottom. So what I do, I bring another refractive index, I bring 2 out here and I bring 3 out here. Now just apply rational number concept. Children, there is no official explanation to this. This is a very, very desi way of understanding. They look like rational numbers. Forget the etas, the 1 and all. Does the 2 and 2 cancel each other? So is it 1 and 3 remaining? Right? This is one formula. And this formula in your book will be written as 3 with respect to 1 can be eta 2 with respect to 1 and eta 3 with respect to 2. If you mug it up in this manner, there is ample chance in exam you will do 2, 3, 3, 2, 3, 1, 3, 2, 3, 2, 2, 3. But all you should do is, given any medium, we have to swap. Say we have to swap. First, what we will do, whatever data is given, write that data, and you can introduce one patal lok in your mind and then write them in this manner. Ultimately, I have to get a 1 by 3. Suppose there was medium 2, then there was a medium 4 also. They make it more complicated. Let's make it a little bit more complicated, okay? Let's make it complicated now. Let's make this complicated. 2. So I have eta 2 with respect to a medium 4. But I want 3, na? 3 and 1. So I introduce another refractive index. What should I do? I bring a 4 and a 3. As much as you want, you can play. 2 cancels, 2, 4 cancels, 4, 1 and 3 remains. Easy work, nahi? Samajh mein aaya? I am not writing this formula as a standard. Like in here, I wrote some standard formulas. I am not writing here. The standard formula is this. But I don't think even if you ask me to write this formula straight away, I will be writing it correctly. But if given me to split this, I'll split and write it correctly. Does anyone have any issue understanding this formula? इसको मैं क्या बोलता हूँ? पाताल लोक फॉर्मूला. ये पाताल लोक फॉर्मूला से सब प्रॉब्लम सॉल्व होगा. Any issues? बोलो. अगर issue नहीं है, then I will stop the screen and I will go and we will start solving problems on refractive index. Amish, did you understand how to apply?
Yes, sir.
Across?
Sir?
Yes, sir.
So we only draw the dotted line here, like into the
Dotted line and everything, nothing on your answer script. This can be in your rough work or whatever. Dotted line is in your mind. Now when we see the dotted line is something like when you first learn skating, they will be putting those traffic cones so that you skate in that alley only. Now when we do our problem, we will remove this dotted line. Dotted line is not allowed. Dotted line is for my mental satisfaction and simplicity. We will solve problems. We will solve exact board problems now where this dotted line is not allowed to you. We will see how to do it. Agreed? Shall we? Can I swap now? Okay. So let's say we minimize this, and so let's go on to our numericals mode. Hey. 1 minute, huh? Mode teaching. So there are many problems. Since this will go as a video to you, all the problems are there. Okay. Today, only the thing is the class notes will be in two different softwares we are using parallelly. Let's take our first problem. Can you read this? All of you can read this. Online children, you can read this. Okay. Light travels through water. Don't try to solve it. I don't want anyone to solve this problem. Light travels through water with a refractive index of 2. I just want you to understand. There is no, don't try to solve and try to prove कि हाँ मैं कर सकता हूँ. Light travels through water with a speed of 2.25 into 10 to the power 8. This is 10 to the power 8. Okay. What is the refractive index of water? Let me just try and see whether I have understood what the problem is telling me. The problem is telling me that there is water, right? And light is traveling through water. So light must be coming from air, and the light has traveled in this way. Air, the speed is c, and in water the speed is whatever the speed is given, 2.25 into 10 to the power 8 meters per second. They are asking me, and this is water, they are asking me what is the refractive index of water. Did they tell me that what is the refractive index of water with respect to something? Did they use this word? No, they just said what is the refractive index of water. That means if I try to work out this solution, I would say that what is my given data? My given data is speed of light in water. How much is the speed, children? I call it VH2O. 2.25 10 to the power 8. Right? Now they're asking me to find. What did they ask me to find out? What is the refractive index of H2O? Now I'm calling this as eta H2O, because they are asking me absolute. And I write eta H2O is equal to C upon VH2O. And here I write C is equal to speed of light in air. After this, I won't do this problem because I think you are able to do. I will be only solving problems till this stage. Have you understood this problem? Pretty easy. No confusion. No one. Chale, next problem. Anurag, all of you clear? You can solve it at home. You know how to. Aditi beta, is it getting clear? This one? Okay, let's take the next problem. Interesting. Let's understand. Light travels from a rarer medium 1 to a denser medium 2. So let me make my sketch. Light is traveling from a rarer medium to a denser medium, and the rarer medium is 1, the denser medium is 2. Obviously, my diagram would be something like this, and it will bend this way. Rarer means the speed is much more, and if you would like to make it more proper, then this is my normal. This is the diagram, correct? The angle of incident and the angle of refraction. So that's not 450, that's 45 degree. So the angle of incidence is how much beta? 45 degree, and the angle of refraction is 30 degree. So see, the refracted angle is this. Calculate refractive index of the second medium with respect to the first medium. Now, in this problem, I would write given medium 1, which is rarer, and medium 2, which is denser. Then angle of incidence, which is I, is equal to 45 degree, and angle of refraction, which is R, is equal to 30 degree. The first thing that I have to find to find a refractive index of, read it first, refractive index of what? Second medium, medium 2 with respect to medium 1. Clear? So for the first part of the problem, I would write refractive index of 2 with respect to 1. 1 means the incidence from should be from there, sine of I, and the diagram is exactly tallying, which will be sine 45 divided by sine 30. Rest you can do, sine 45 1 upon root 2, sine 30 half. So you will be able to do this problem. Any doubt? Then it says refractive medium of 1 with respect to 2. 1 with, now the next part you have been asked to find out what is 1 with respect to 2. So you use the formula. Just now we had learned this formula. Invert it. 1 with respect to 2. हाँ रेसिप्रोकल नहीं, वही तो पूछा ना, इसको दोबारा करने की जरूरत नहीं, करोगे भी तो वही आंसर आएगा. 1 with अच्छा, what is it written? 1 with respect to 2. Let us now say हमें ये फॉर्मूला पता नहीं है, we don't know this formula. Question is what? 1 with respect to 2. Okay, can I change the screen a bit? They are asking me to find out 1 with respect to 2. At this moment, what all things come in my mind? 2 is on top, therefore incidence should be from the top. 1 is below, so here light should enter. I construct my own diagram. 1 with respect to 2. This is 1. And remember, 1 was a what medium? A rarer medium. And this is 2, which is a denser medium. Now light is coming from a denser medium. What will be the speed of the light? Less. It will be more bent towards the normal, and it has to serve the same geometry. So this angle will be how much? 30 degree. And it will refract out away from the normal now. So this angle would be 45 degree. So if you want to solve it by Snell's law, then you will write eta 1 with respect to 2 is sine of I, which is sine 30, divided by sine of R, which is sine 45. Even you can solve this way also. Your concept should be fully clear. But rather doing all this hodgepodge, you know eta 2 with respect to 1 is same as 1 upon eta 1 with respect to 2. Any child who has not understood second part and my explanation how to do it, in case you forget, can still ask. Clear? Right? Patal Lok has still not come. Which question? This question? You want me to repeat the explanation of part 1, Shreya, or part 2? Oh, whole, okay. So the question says, light is traveling from a rarer medium. That means this is my diagram, this is my diagram. It is traveling from a rarer medium. That means it will travel much more faster. And it enters into a denser medium, creating an angle of 45 degree as incidence and an angle of 30 degree as refraction. The first question says, find the refractive index of second medium with respect. Respect is always on top. Find the refractive index of second medium with respect to first medium. Second medium, respect, you give more ijjat to 1. So this is sine I by sine R. 1 is always where light is coming from. So sine 45 by sine 30. Shreya, did you understand this much part? Okay. And relax. Okay. Aram se kuch khana wana hai, you can eat. No issues. The second one is, it says, find now what is the refractive index of 1 with respect to 2. 1 with respect to 2. In these cases, you have to just somersault them. 1 with respect to 2 is same as 1 upon 2 with respect to 1. And say you don't know this formula, you can apply your common sense. 1 with respect to 2. That means 1 is where it is entering, 2 is from where it is coming. 2 is denser, 1 is rarer. So if it will be a 30 here, it will be the same 45. Same thing, right? You watch it from this side, you watch it from this side. So here there is another thing. Have you seen in your windows, you have got those blinds, which if you pull, they can actually become, in movies they show. Again, मैं उसका मुंह नहीं देखना चाहता हूँ. They make the blind like this. You know what is it called? What blind? Can anybody tell me what is the word of that, the curtain? Have you seen those? It's called a Venetian blind. What blind? Venetian blind. So you'll have a lot of parallel strips, and they can actually open up. They can open up like this, and then you can take it in this way. But there's a catch to it. English is very beautiful here. If you are seated inside the house and you are actually seeing at the blind, what is this blind called? You know, Venetian blind. And if you are at balcony and you are seeing this blind, what is this blind called? Persian blind. Venice and Persia. From that, this name comes. So very easy. But will the person change? No. Somersault it. Shall we go to the next problem? Now we will see. How much time will light take to cross 2 mm glass plate? Okay. Oh, this problem is not there in you because this is previous case. Thickness, you don't know how to do. Leave this problem. This is not there. Okay, next. Can you now do this? Calculate the speed of light in water of refractive index 4/3. Don't just straight away start going and taking up your book and getting formulas. What have they asked you? Speed of light in water. Basically, the question is asking me to find VH2O. And they say that the refractive index 4/3. That means eta H2O is a value which is 4/3. Agreed? Now start constructing that formula. Eta H2O is same as beta eta H2O with respect to air. Right? That means this formula should be a C upon VH2O. And in terms of diagram, it should be that light is entering from air and then it is going inside water. And this angle should be small, this angle should be more. Very easy. You'll be able to calculate now. Just put the value of C and put the value of 4/3 out here. So you'll be able to calculate. So if you see what is VH2O, VH2O will be C multiplied by eta H2O. What is the value of C? 3 into 10 to the power 8 multiplied by 4/3. 4/3?
No, sir, it's on the opposite. It's 3/4.
So it is 4/3, so it will be 3/4. Acha, why it can't be 4/3? No, why it can't be 4/3? Say suppose you have written 4/3 in exam. Then what will be the value? 3 cancel, 4 into 10. You are saying in light travels in water at a higher speed than in air. That should strike your mind. You're a student of physics now. You cannot say that sir has written, I have written it wrong. But how to understand? If I have written it wrong, 3 cancels 3. What is the speed of light in water? 4 into, is this possible? Light is fastest in air. So that is where we are going for wrong. So this should have been 3/4. Easy. So far. Chale. A ray of light travels from air to glass. A ray of light travels from air to glass. Now diagrams have become so easy. Anvita, bolo. When you were doing at that time and now, isn't it coming absolutely easy? Now you must be thinking, why did I score wrong in that exam, right? Air to glass. And the refractive index is given. Whose refractive index? Glass. What type of refractive index is it mentioned? What type of refractive index? Absolute, because the case is happening from air to glass and they have said, so eta glass is given as 1.5 and a ray of light passes at an angle of 30 degree. So that means this angle is 30 degree. Ray of light passes from air to glass at an angle of 30 degree. Calculate the angle of refraction. Will you be able to calculate the angle of refraction? Why not? You would say that eta glass is same as eta glass with respect to air, which should be equal to sine of I over sine of R. Now we are given that this value is 1.5. A 1.5 can be treated as what, beta? 3/2. Decimals are always bad for health. So 3/2 is equal to sine of angle of incidence. So sine of angle of incidence is sine 30, which is half, divided by sine of R. So my sine R goes this side, becomes 2 sine 30 right? 2 sine 30 divided by 3. All of you understood this calculation? 2 sine 30 divided by 3. 3 sine r is equal to 2 sine 30, right? So sine 30 is how much, beta? Half. And this is divided by 3. Divided by 3 means into 1 by 3. That means my r should be equal to sine inverse 1 upon 3. We can't calculate further than that. We don't have a calculator. This, just try to understand. In trigonometry, we say sine 30 is equal to how much, beta? Half. That means sine inverse of half should be equal to 30 degree. Inverse, if this is COVID, inverse is covaxin. If you give inverse with the function, you just get the argument. Sine inverse of sine 30 is 30. Inverse.
It's different from 1 by.
It is not 1 by sine. It is an inverse function. What you input here, you input degrees here, you get values. Here you input values, you get degrees. Ulta microwave ulta chal raha hai isme. This is what will be there in your first chapter, grade 11, functions and relations, where you will talk about domain and range. What is input, what is output. Clear this problem? Anyone has any issue? Easy problems. Did I pick up the right file or not? Now I'm having myself a doubt. A ray of light incident on a glass slab at an angle of 45 degree. If the refractive index of glass is 1.6, these are all degrees, huh? 450 cannot be an angle. 360 is the maximum. You'll be able to do this? Not an issue? Okay. The refractive index of diamond is 2.47. Diamond is supposed to have a very high refractive index. So much that it bends light in such a manner that light bahar nikal hi nahi pata hai. We'll study about that, though not in your syllabus, but we'll cover it. Something called total internal reflection. Okay. Next thing I'll teach that only. Now, it is given that the refractive index of diamond, and this is a standard value. So this is with respect to air. It's an absolute refractive index, which is 2.47. Have you, so do you see how greater the refractive index, more is the bending capacity, more is the optical density, more is light getting slowed down. You are making the life of light miserable. This data is just like the traffic condition inside the medium. More is the data, thick is the traffic. Light cannot travel. Okay. And that of glass, beta glass, is how much, my bacha? 1.51. How much faster does light travel in glass than air? So basically we have to find out Vg is to Vd, diamond. If this ratio we can find out, what is this? This is Vg upon Vd, and say we find some value x, so we can say glass is equal to x times of diamond. Diamond will be slow, we know that. That's what they're asking, how much fast. So you have to find this ratio, Vg is to Vd. Shall we? No, not subtraction. We will not do. This is a ratio. How much faster? How faster means what? How many times faster are you? Right? Subtraction also you can do if you know the absolute value. So let's see. The absolute value we will never know. Nobody has told us the value of speed of light here. Why your assumption? What Ananya is asking, they have said how much, say my age is 48, your age is 15, or say 16, say 16. How much elder am I to you? So if you know the respective ages, you can find the difference. But if you don't know the respective ages, have we given any data for this? Then the best way is to say Jaideep's age is to Ananya's age, a ratio. So you will say Jaideep is equal to so many times Ananya, but we don't know the exact numbers. वही करना होगा, इसीलिए subtraction नहीं होगा. समझ में आया? Okay. So let's write eta diamond. Tell me बच्चा, what is eta diamond? Eta diamond is C upon V diamond. Any issues? No issues. So let's write eta diamond. Eta diamond is 247 by 100 is equal to C by Vd. 2.47 is 247 by 100. Clear? Similarly, what is eta glass? eta glass is C by Vg. So in case of eta glass, can I write 151 by 100 is equal to C by Vg? All right, children. I name, okay, now what I do, I'm cloning this, I'm cloning this equation, right? And I'm cloning this equation. These two equations I've cloned up. Okay, this is one equation and this is another equation. I'm saying divide one by the other. So let's divide one by the other. 247 upon 100 is being divided. So it will be into 100 by 151. Agreed? And on that side, it will be C upon VD into VG by C. Apna kaam ho gaya. CM detham. 100 detham. So what do you finally get? You get a ratio Vg upon Vd is equal to 247 by 151. If you want, you can use decimals. So they are roughly approximately. Now you can find out the ratio. How much is one more than the other? So automatically is this value not more than 1? Yes. So the glass speed will be more than diamond speed. And if you're very, very eager to know, when will my Casio come to use? I hate calculations. 247 divided by 151, that's 1.63. Hey, you भी calculator मारा होगा 100%. Or Vg is equal to 1.63 times of V diamond. So now what will you answer? Light travels 1.63 times faster in glass as compared to diamond. Will you understand this problem? So many problems on refractive index can be there. Next. Oh wow. The refractive index of glycerin is glycerin, or somebody says glycerine. Okay. Oh yeah, please. Yeah, check it. Get me your digits. How much? 1.63. Hey, you don't know this? This is the new. Do you know what is get me your digits? You don't know. Hey, come on. How can you all be so backdated? Nowadays, you know, the very hip modern girls does not ask another girl. A girl does not ask a girl, what's your number? Do you know that or not, Shreya? A girl doesn't ask a girl, what's your name? Hey, babes, can you tell me your digits? Digits means phone number. And I'm pushing off his said as, chal, I'll bounce. Look here. Me at this age, I know. Yes, know you. Get me your digits means give me your phone number. Yeah, tell me.
If you know BG and BD,
Which one? How did I get this?
yeah, BG is 151 by
Huh?
240.
First of all, forget everything. How to check that I'm an idiot or not? I mean, let's enjoy the discussion, okay? Because somebody else is supporting you from here. Let's check. That's it. Girl, get your digits correct first. Glass and diamond, where does light travel faster? Glass. Diamond, it doesn't travel because look at the figures. 2.47 onward. 2.47 means more traffic, right? So if you see this ratio, Vg will be some blah blah into Vd. Blah blah has to be more than 1, my dear. Then only Vgs will be having a value more than 1. 151 ऊपर होता तो slow जाता, मजा ले रहा है ये पूरा तुम्हारा, हाँ? 151, if it would have been on top, it would have slowed down. This is the beauty. We will not check our calculations. We should just look at it and answer. In fact, our professors in engineering were such that if somebody had written this 151 by 247, he will make a negative deduction from you saying that I'm not worried about the calculation. I'm angry at your foolish level that you are writing that statement. That means you didn't understand the chapter. And I'm so glad that both you girls brought up this topic. There's nothing to demean. But one thing will remain in your head, that if something is fast, the ratio has to be more than 1. And for that, let's go back to grade 8. It has to be an improper fraction where the numerator should be more than the denominator. Did you get your digits right this time? Good. Shall I go ahead? All skibbities, you know. Hey, Ali, skibbity matlab kya hai? What is the what is the meaning? It is the name of a. नहीं बोलो ना. Anurag, what is skibbity? Can you throw some light? I've heard skibbity toilets. What does skibbity? मैं कुछ भी नहीं पता. They don't know. Loki dead. Guys, you couldn't slay it, you know, in your language. That's what I can say. Shall we go to the next one? Okay. The eta of glycerine or glycerine is how much? 1.46. That means obviously this is with respect to air. Clear? Next, what is the speed of light in air? They've asked, what is the speed of light in air? If in air has become twice. If its speed in glycerine, Vg or V glycerine is 2.05 into 10 to the power 8 meters per second. Pretty easy. Eta glycerine, which is nothing but with air, should be C upon V glycerine. You will be able to calculate now. All data are given to you. Eta is given to you 1.46. Chalo, next problem. All of you perfect. So many problems you're doing today. See? Oh yes. Refractive index of glass and that of diamond is 2.4. So this problem tells us eta glass is equal to how much, bacha? 1.6. What is eta diamond? Eta diamond is 2.4. Calculate 1. Refractive index of, calculate 1. Calculate refractive, and now we will need Patal Lok formula. Refractive index of demand with respect to glass. Demand with respect to glass. Now we need Patal Lok formula. So in our mind, we have to get this ratio, and we have to get this ratio from here. So let us construct what? One Patal Lok. I'm doing it in black color. And what all data am I given? I want glass on top. See, I want glass on top. Very dangerous, huh? So I want glass on top. I can put air at bottom, right? And then I need to abolish air. So I'm putting air and I'm putting diamond out here. Okay, children, have you understood this? Forget what you are given. Forget what you are given. You need to find out diamond with respect to glass. Children, this is G. My handwriting is very bad. This is G. This is G. Right? I need to find out diamond with respect to glass. So here I have done my Patal Lok. Correct? I need glass on top under any circumstance. So I put air in bottom. Then air out here. Air out here and diamond. Now just check. This data is something that the question has already given you. This data is something which the question has already given you. However, this is something that the question has not given you because this is glass with respect to air. But we know the person who is our maternal uncle, for that person he will become our bua. Yes or no? So how to change this? This can be written as 1 upon eta G with respect to A multiplied by eta D with respect to A. Did you understand this or not? We just reciprocated. Now you ask yourself that is this data given to you? Yes, this data is given to me. My life has become very easy now. So what is the final answer? The final answer would be 1 upon, what is G with respect to A? 1.6. 1 upon 1.6 multiplied by A with respect to D, 2.4. Is this ratio coming more than 1? Yes, because you are seeing diamond with respect to glass. Then this is a denser medium. Enjoy physics. And this is a rarer medium. Now glass has become rarer. Glass was a very dishonest boy. But you are comparing it with super dishonest boy. So glass became honest. Now this is rarer, this is denser. So ratio will come more than. We are correct. Always remember, like the movie Sultan. Once you hit a guy, you don't look back. You know he is knockout. He can't get up. वैसे मैच करो. There is one catch in the last T20 World Cup against Hardik Pandya's bowling. He didn't even look at. He knew the catch will be taken. He just went and celebrated. A lot of reels come on that. Confidence should be like that. Clear? Understood? Anyone who has not understood, I'm ready to explain again. Clear? Can you explain your friends now everything related to refractive index? Because all of them have some sort of ulcers with respect to this topic. That's why I say, if you have understood this, you have understood refraction very nicely. And if you can retain it for one more year in your tummy, like hibernation, and you are going to study physics in 12, and by that time, this will be like crystal clear with you. Next. A ray of light is traveling from glass to air, mind you. The ray of light is traveling from glass and it is traveling to air. That means it is coming from denser to rarer. Our diagram would be something like this and it will run away like this. So this would be our I and this would be our R. Are you able to construct this diagram or not in your mind? Because you're coming from, huh? ईटा कम ही होगा क्योंकि आप rarer में जाओ. Now let's see what it says. Light is coming from glass to air. The angle of incidence in glass is 30 degrees and the angle of refraction is 60 degrees. Our diagram is exactly matching, man. This should be more than this. What is the refractive index of glass with respect to air? Please, no, see, glass with respect to air, they have asked. Don't do sin I by sin R. We'll not do sin R also. We'll go by sin I by sin R. But if you do sin I here, I should always be in the medium from where it is coming. Now, I is in which medium? Glass. Garbar ho jayega. But I can write this as 1 by eta air with respect to glass. I can write this. Correct? That means this is the perfect scenario of my diagram. Ray is coming from where? Glass. So I would write sine of 30 divided by sine of 60. Half divided by root 3 by 2. Clear? Now you are trying to find eta glass with respect to air. Glass with respect to air, eta's value should be more than 1 because glass is giving you more traffic. Yes, denser. Did you understand this one also? Very good. You all are very smart children. I really like it. ठीक है बेटा नील सो तो नहीं गए ना? अरे वाह. Excellent. Anurag, all fine? Acha. Slowly Anurag's forehead won't be seen because he's into the new style of growing hair. So there is to be, you know this rock band Guns N' Roses? You guys know nothing. Guns N' Roses is Welcome to the Jungle and all this. Okay, Guns N' Roses. Then why are you silent? Guns N' Roses has their lead guitarist is Slash. He never shows his face. Log into a song called November Rain. So you'll see there are 2-3 very good lead guitarists. One is Jimi Hendrix, one is Slash, one is David Gilmour. David Gilmour plays for Pink Floyd. He's 80 years above. They say God is there in his fingers. वो सब तुम्हारा बच्चा सब है, ठीक है? So Slash never shows his face. His hair is this side half, and he will always have one cigarette in his mouth or in his hand, and he'll play his lead guitar. So he's our new Slash. He's Splash because his hair is also on his forehead. and in his footsteps is walking his classmate. Both of them after in 11 they will be now wearing headbands. Very good. On the path of progress, let's go to the next problem. A ray of light is traveling from air to water. So how will be the diagram? Like this. This is air, this is water. What is the angle of incidence in air? They've asked you what is the value of I. If the angle of refraction is how much? 45 degree. Obviously, this has to be more than that. Take refractive index of water, means eta H2O with respect to air is sine of I upon sine of R. You'll be able to do? No issues? Yeah. Now you'll have become champions. A water tank, no, you will not know. This is a grade 12 problem. This is apparent depth and actual depth. When you enter into a swimming pool, don't you find that the swimming pool is less deep?
So this concept is there.
This concept we will also study. Just that we will not do the problem. The problem is refractive index is equal to real depth upon apparent depth. That is the formula we use. So it's gone. We're gone. We're done with this. So we have got 2 minutes more of time, 5-10 minutes. So give me some time that I go back here. Yes, we were here. So is refractive index clear? I said that I will explain one more thing in context to refractive index. Okay. Something which is known as, this is not in your course at all. Earlier it used to be there, but in Cambridge and ICSE it's all there. It's called total internal reflection. Total internal reflection. Total internal reflection. Mind you, it is nothing with refraction. Okay. So let us see some scenarios. Right. Imagine this is a rarer medium and this is a denser medium, right? And this is not there in your syllabus, huh? But the plight of studying with me is that all these things, some things I teach which is not in syllabus. Many people make my photographs and then use compass as a dartboard. But for your good only I am teaching. So please bear with me. Okay, let's say, okay. From a denser medium, let's say this is my incident ray. Do you agree? Whenever there is an incident ray at this medium, then there has to be a refracted ray and it is going in rarer. So the refracted ray would be something like this. Do you agree or not? This is a simple diagram. Now, what you do, this is my angle of incidence, I. Start increasing I. Okay, I start increasing I and I make my I something like this. Like this. Zyada ho gaya. I make my I say something like this. Say this. Then what do I expect my R to be? My R will further flatten out from its region. Is this understood? Right? If I start increasing my I more, this was, say this was my I1. This is I1. This is I2. I'm increasing. I1, I2. This is I1. This is I2. I'm increasing I. I am further increasing I now. Let's say that this is now my I. What do I expect for my R to be? My R will be something like this now. Right? Don't you think that there will be one angle where if my angle of incidence is like this, now it won't be a straight line because I'm changing the color just for your simplicity. The refracted ray will become like this. What is the angle of refraction now? 90 degree. Angle of refraction is always angle with the, just because I said this is not in syllabus, we will not pay attention. As I can say, this is my angle of incidence and my angle of refraction is now what? 90 degree. Do you agree? This angle of incidence is something special. This angle of incidence is known as critical angle. What is critical angle? Critical angle is that angle of incidence at which the angle of refraction becomes 90 degrees. So you have lost your refracted ray. Do you have the refracted ray now? No, you don't have the refracted ray. And now I am creating another angle, another incident ray with an angle here, I, say I3, which is greater than IC. Greater than IC. Understood? This ray won't be able to escape out. It will come back reflected. This phenomenon is called total internal reflection. In total internal reflection, the angle of incidence is more than the critical angle. As such, refraction as a phenomenon is lost. Everything that is happening is reflection. Now children, one more thing. So you might say, यहाँ reflection नहीं था क्या? यहाँ भी था, कम था. There was some reflection here also. Because reflection will always be there. Reflection. But in this case, everything that was incident got reflected. This is what happens in diamond. This is a denser medium. If a ray is inside diamond, it undergoes, and diamond's critical angle, the critical angle IC for diamond is how much you know? Is as less as 24 degree. 24 degree is a very small angle. Any ray which is more than 24 degree in diamond cannot escape diamond. That's why they are the best friends of a girl and make you spend more as a boy. They glitter. Have you understood? This phenomenon is used in, all of you must be using what? Airtel, Geo. What is the technology you're using? You're using fiber optics. The wire which is coming and sitting inside your router is not carrying any electrical signal at all. You might be thinking that wire which is going into a router is carrying electrical signals. No, this router is a optical tube. It's a tube. Understood? If it is an electrical signal over length, they have studied, Rockwell people, you have studied resistance. So if the length increases, the resistance will increase. So the electrical signal's intensity will die down. That is what used to happen earlier days when we had cable TV in home. You remember? One wire from outside used to come to your house. So sometimes you complain, Mara, reception is not good. So they will put one boosters. Boosters are put to increase the strength. From here to that apartment, the signal will die down. Why is fiber optic so good? Why does it give you so much speed? The fiber optic is actually a tube and it has got two layers inside it. Okay. The inner layer, there is an inner layer. This is known as cladding. This we call as cladding. And this is the inner layer. This is the inner layer. The refractive index of the inner layer is much, much higher than the refractive index of the cladding. It is manufactured in such a way. Have you understood? Refractive index of the inner layer is much, much higher than the refractive index of the cladding. As a result, if any light ray is allowed to get inside this optical fiber, it cannot escape. It only undergoes multiple internal reflection. So if I input one optical signal from here and 300 kilometers later, if I take out the same optical signal, there is no loss of signal at all. Light just comes out as light. Next time when the Airtel or Geo technician comes to your house, you will see he will have one scissor which he is very, very concerned about. He's very possessive. And with that scissor, he'll just strike out your cable. And in fact, if you see the cable properly like this, that is what you all don't do. You all think technician aaya hai, karne do. Ask him. You can see the red light inside it. A light is actually going inside your modem. The modem is then again demodulating it and converting the light back to electrical signal. Means when it is traveling from, say, an apartment, which is their apartment, say this girl is at Ramki Towers. From there to Pebble City, we have the same Airtel cable coming. So much of distance. Won't the signal die down? The signal doesn't die down because, and under the seabed, the ocean beds, we have got lots and lots of this cable through which the internet is running. In India, the internet enters through Chennai. Chennai is our hub where the India's internet enters. To boost Northeast, India struck a deal with Bangladesh so that Airtel will put up another, because you have to get a shore, seashore. After the insurgency that happened in Bangladesh, I suppose you know, when the government toppled, the new government cancelled that deal. These are geopolitics. They wanted to cripple India by not going with that deal so that the northeast part of India, otherwise another way is to get through China. China won't give us. We need through a source. That was the deal that was struck. They cancelled that deal. Now you understand. Sometimes there will be cable cut in undersea. If undersea cable cut happens, then all these internets will fall. And this is also used in endoscopy. God forbid that happens to you. Endoscopy is when a tube is inserted inside your foot pipe. Suppose somebody wants to check your GI tract, gastrointestinal tract. How they will check? A tube will be inserted. That tube will have a bulb. So these endoscopic tubes and all. This is total internal reflection. The entire communication, you say, I've got Geo fiber, I've got Airtel fiber. They don't have any electrical signal coming. What is coming? Light is coming. And these are many such strands of fiber. It is as small as your hair. And when he will snip it, just one. In childhood you had these teddy bears. Once the teddy bear tears off, don't you see glass wool coming out? The fibers are like that. And you can actually see the light. The main cable which is going into your geo router, just take that cable out and see it properly like this. You can see the red light. That is because it's going through total internal reflection. ये कोर्स में नहीं है, लेकिन ये जानना एक अच्छी चीज है. It's not transparent. That's why I said, see, we have nothing to do with transparent or translucent or opaque. Even through opaque light leaks, our job is, once this ray has got in, don't let him go out. Make him reflect internally as much as possible. So you design your material in such a way that its refractive index should be very, very high. Diamond's refractive index is 2.47. You design it much more than diamond. Diamond se nahi bhaga, to how will you explain it? And that is called the core. And the cladding will be having, the core will have less, cladding will have more, and then understood? This is not in your course, but you should know what is total internal reflection. In our next class, we will be studying some effects of refraction, like why does a swimming pool appear, like we go inside like this now? Why does it appear with less depth? Why does a coin submerged in a glass appear to be at a raised? Why does a stick appear bent? Why does Jaideep Das appear so monstrous, which he is not? All in next class. Correct? So enjoy your Friday night, gala night, and